Hi everyone, hope you all are good. So we're going to start with grade 10 maths. So we're going to start with the chapter graphs of quadratics. So you can find the chapter graphs of quadratics in the Nelson grade 10 book. Nelson grade 10 books, and the chapter is the lesson on page 134. The lesson we're going to cover today is exploring quadratic relations. Got it? We're working on grade 10 Nelson grade 10 book. The chapter is graphs of quadratic, and the lesson we're going to cover is exploring quadratic relation, that is on the page 134. Got it? Okay, here is the book graph of quadratic relations. So let's start with the lesson. Okay, let's just do the lesson. Okay, words you need to know. Match each term with the correct diagram or example. You are given diagrams, you have to match them. Which is the linear equation? The linear equation is this one is the linear equation. Got it? Y equals 3x plus 5. This one is the linear equation. That is the answer for the option number A. Got it? Okay, then B is first differences. Which one is the first differences? This one is the option number B, first differences. Got it? You can see here you calculated the first differences. So all of them have the same best difference, first differences. Got it? Then C1 is distributive property. This is actually the distributive property. A times B plus C. So it would be AB plus AC. That is option number C. Got it? Then you have to scatter plot. Which is the scatter plot? This one is the scatter plot. Got it? This is option number D. Then you have E is the intercepts. Intercepts are the point where the graph is touching the x-axis and the y-axis. So this is the intercepts. Got it? Then the line of symmetry. This is the line of symmetry. Line of symmetry is actually the line that divides the shape into two exactly equal parts. Got it? Okay, that is just a review. Got it? Okay, now let's just discuss some of the concepts and then we'll go to the start the lesson. Okay, some okay, multiplying a polynomial by a monomial. So that is basically here we are going to use the distributive property. How can we use? The first one is 2x times 3x plus 5. So let's start with the first example, 4 times x plus 3. 4 times x plus 3. Basically, that is the distributive property we're going to use. You have to multiply 4 times x. Then you have to multiply 4 times 3. It would be 4 times 3 is 12. That's how you apply the distributive property. So it would be 4x plus 12. Got it? Okay, let's just do another example. I'm going to do the third one. Negative 3x square x minus 2. Negative 3x square x minus 2. So you have to do negative 3x square times x. So it will be negative 3x cube. Then you have to multiply it to negative 2 to negative, and negative with positive, and 2 times 3 is 6x square. So it would be negative 3x cube plus 6x square. Got it? Okay. The next one is 4x times 2x minus 3. 4x times 2x minus 3 plus x times 7 plus 5x. Got it? So just multiply 2x to 4x to 2x. So 4 times 2 is 8. It is 8x square. Then 4x times 3 is minus 3 times 4 is 12x. So you have to do the same thing over here. 3x times is 7 times 3 is 21x. And 3x times 5x is 5 times 3 is 15x square. Got it? So you can collect the like terms. They are the like terms. Got it? 15 and 8 is 23x square. And negative 12 plus 21 is plus 9x. Got it? 21 minus 12 is 9x. So it is 23x square plus 9x. Got it? So it is 23x square plus 9x. Got it? Okay, let's just do the last one. negative 4x times x cube minus 3x, 3x square plus 2x times 5x square minus 3x minus 6x square times x cube times x minus 3. Okay, 4x times x cube is negative 4x 4. Then negative 4x times 3 is minus minus plus, and 4 times 3 is 12x cube. Then 2x times 5x square is 5 times 2 is 10 and x cube. Then 2x times negative 3x is minus 6x square. 6x cubes times x is minus 6x4. Then 3 times minus minus plus 3 times 6 is 18x cube. Just collect the like terms 4x4 and 6x4 minus, both of them are negative, so it would be negative 10x4. Then 10x cube and 18x cube is 28x cube. This is also cube. 12, 6 and 12. 18 and 28 and 12 is 40x cube and minus 6x square. So it is 10x4 plus 40x cube and minus 6x square. Got it? Okay, you can complete the rest. Got it? Okay, here is the practice question. Let's just start with the practice question. Determine the value of y for each given value of x. You are given with the value of x and equation. You have to calculate the value of y. Got it? Y equals 2x minus 3. Okay, just 1 minute. Okay, so the question is y equals 2x minus 3, and you have to calculate for equals 1.5. So just replace the variable with the value. Got it? It is 2 times 1.5 minus 3. So 2 times 1.5 is, it is 2 times 1.5 is 3, and 3 minus 3 is 0. Got it? Okay, the next one is, let's do C part. Y equals x square plus 2x minus 1. Y equals x square plus 2x minus 1. And you have to put x equals 4. Got it? Just replace all the x with the 4. Here you have 4x square plus 2 times 4 and minus 1. So it is 16 plus 8 minus 1. So that would be 23. Got it? Okay, let's just start with the next question. The next one is question number 6. I'm going to start with. Got it? A cell phone plan costs $25 each month plus 0.10 per minute of airtime. Make a table of values, construct a graph, and write an equation to represent the monthly cost of the plan. Got it? Okay, let's just make a table. Okay, so minutes and cost. So the cost is $25 each monthly plan plus 0.10 per minute of airtime. Got it? So it is, for 0, it is $25. Got it? Then for 100, it is 25, and plus 0.10, that would be 35. Then for 200 minutes, it is 45. Then for 300 minutes, it is 55. Then for 400 minutes, it is 65. You have to make a table. It would be a straight line. Got it? You have to write down the equation. Equation would be C equals 25 plus that's how I calculated the cost. Got it? It would be 25 plus 0.1 because here you are given 0.10 per minute of airtime. Got it? So it would be then 25 plus 0.1 times t. So just put up the values, then that's how I completed the table. Got it? Okay. The next one is, let's start with question number 9. Okay, determine the x-intercepts and the y-intercepts of the relation. Got it? You have to calculate the x-intercepts and the y-intercepts of the relation. So the first one is y equals 2x minus 3. So how can we calculate x-intercepts and y-intercept? That is just a quick review. So calculating intercept is very easy. When we have to calculate the x-intercept, you have to substitute y equals 0. Got it? So it would be 0 equals 2x minus 3. It would be then 2x equals 3 and x equals 3 over 2. That is the x-intercept. Right here you can write 1.5. And y-intercept, what you have to do? For the y-intercept, you have to put x equals 0. So just replace the x with 0. It is y equals 2 times 0 minus 3. So 2 times 0 is 0 and 0 minus 3 is minus 3. So that would be y equals minus 3. That's how you have to calculate the y-intercept. Got it? Okay, you can do the rest of the questions by yourself. Let me just move on to question number 10. Okay, let's see. Okay, it's okay. You can do the rest of the questions by yourself, and that is exploring quadratic relations. So now we're going to learn what are the quadratic relations. So quadratic relation, here is the standard form of the quadratic relation, that is y equals of relation of the form y equals ax square plus bx plus c. Whenever you have written something like this, ax square plus bx plus c, that means the equation is the equation is the quadratic equation. Got it? It would be y equals ax square plus bx plus c. Got it? That if you have any equation looks like this, that means the equation is that is the quadratic equation. Got it? Okay. So that is the standard form of the quadratic relation basically. Got it? Okay. Okay, the summary of the lesson. The graph of any quadratic relation of the form y equals ax square plus bx plus c, where a is not equal to 0, is a parabola that has a vertical line of symmetry. So that is the basically the property of the quadratic relation. Their graphs look like the parabola. Got it? Either it opens upward or either downward. Any relation described by a polynomial of degree 2 is quadratic. So any relation that is at the degree 2, that means that is the quadratic relation. Got it? Okay, for the quadratic relation y equals ax square plus bx plus c, the second differences are constant but not 0. That means if you calculate the first differences and then the second differences, their second differences must be constant, not 0. Got it? When the value of the a is positive, the parabola opens upward, and if it is negative, the parabola opens downward. When the value of a is negative, the parabola opens downward, and the second differences are negative. Changing the value of b changes the location of the line of symmetry of parabola. The constant c is the value of the y-intercept of the parabola. That is the explanation of this equation. Got it? A point, the a is, if a is positive, the parabola opens upward like this, and if a is negative, the parabola opens downward like this. Got it? The value b is the y-intercept of the parabola. Got it? B is the point where the graph is touching the y-axis, like this is the B. Got it? Because here at this point the graph is touching the y-axis. and well, the C is, sorry, C is the parabola. C is the y-intercept of the parabola. Got it? The B means if you change the value of the B, that means the line of symmetry of parabola is changed. Got it? Okay, let's just start with the exam test with the questions. Okay, which graph appears to represent the relation? So the quadratic relations have the graphs look like the shapes U, either open upwards or downwards. So just C and D are the quadratic relations. Got it? Okay, the next one is the next one is determine the degree of each relation. You have to find a degree. Basically is the power of the x. Got it? The highest power of the x involved. Got it? So the degree of the relation is 1. Got it? Because the highest power of x is 1. Got it? Okay, for this one, y equals x times x plus 4. When you multiply x times x, it would be x squared. So the degree of the relation is 2. Got it? Okay, y equals x square minus 6x plus 4. Here the degree is 2, and for this one the degree is 3. Which relation is in part A has a graph that is parabola? Only this one is the parabola. Got it? You can see the equation. It is y equals x square minus 6x plus 4. It looks like ax square plus bx plus c. So just this one has the parabola. Got it? Okay, let's just start with the question number 4. The question number 4 is calculate the first differences of each set, determine whether the relation is linear or non-linear. If the relation is non-linear, determine the second differences. Okay, let's start with the first one. 10, 20, 30, 40. We are going to see if the relations are linear or non-linear. If the first difference is same, they are the linear. Got it? If the first difference is not same, that means they are non-linear. Then we have to check if it's quadratic. X is 10, 20, 30, 40. And the y values are 21, 41, 21, 41, 61, and I think the last one is 81. Yes, 81. Okay, let's just calculate the first differences. Okay, now I'm going to calculate the first differences. So how can we calculate the first differences? Just subtract these two. You have to do 41 minus 21. That would be 20. Then you have to do 61 minus 41. It is 20. Then you have to do 81 minus 61, that would be 20. See, they have the same first differences. If the first differences are same, the relation is the linear. Got it? So that means this graph shows the linear relation. Got it? Okay, let's just do another one. Let's just do C1. Where is the, okay, 5, 6, 7, 8. Let me just draw the table, write down the table on the board. It is X is 5, 6, 7, 8, and the Y values are -2, -3, -5, and -8. Wait, let me just confirm. Let's just calculate the first differences. Okay, um, -3, -2. It would be -3 plus 2. That is -1. Got it? Then we have -5, -3. It would be -5 plus 3. So it would be -2. Got it? It would be -8 minus -5. So it would be negative 8 plus 5, it would be negative 3. They have the common difference is not same. Got it? Now you have to calculate that. That means the relation is not linear. Now you have to check the second difference. If they have the same second difference, that means the relation is quadratic. Got it? Let's just calculate the second difference. Negative 2 minus minus 1. So it would be negative 2 plus 1, which is negative 1. Negative 3 minus minus 2, it would be negative 3 plus 2, so it is minus 1. See, they have the same second difference, the common second difference. So the second difference is same. That means the relation is quadratic. Got it? Okay. The rest of the questions are exactly same. Got it? You can do them by yourself. Got it? Okay, Jay, let's start with question number 5 is each table of the values represent a quadratic relation. Decide without graphing whether the parabola opens upward or downward. You have to calculate the second differences. Got it? If the second difference is negative, that means the parabola opens downward. Let's start with the first one. The first one is, let me just do it on board. The first one is x and y. The x values are negative 3, negative 2, negative 1 and 0. And the y values are 2.5, 5.0, 6.5 and 7.0. Let's just calculate the first differences. Got it? Okay, the first differences are 5 minus 2.5. It is 2.5. Got it? Okay, then you have to do 6.5 minus 5, that is 1.0. Then you have to do 7 minus 6.5, that would be 0.5. Now just calculate the second difference. If the second difference is negative, the parabola opens downward. If it is positive, the parabola opens upward. Got it? So you have to do 6 minus 5 is 1.5. 1.5 minus 2.5, that would be minus 1. 0.5 minus 1.5, again it is negative. And see, they have the second differences are negative. That means the parabola opens downward. Got it? That means that if the second difference is negative, that means the parabola opens downward. Got it? Okay, you can do the rest of the questions by yourself later today. Got it? Okay, just move on to question number 6. State whether the graph of each quadratic relation opens upward or downward. Explain how you know. Okay, the first one is y equals x square minus 1. Just look at the coefficient of the x square. The coefficient of the x square is 1. That is a positive number. That means the coefficient opens upward. The parabola opens upward. Got it? You have to look at the coefficient of the x square. If the coefficient is positive, that means the parabola opens upward, and if the coefficient of x square is negative, that means the parabola opens downward. Got it? Now see, here you have negative 1 minus 1 over 2. That means the parabola opens downward. Here you have again negative, the parabola opens downward. Here you have again, no, here it is x square 1 over 2 positive. That means parabola opens upward. Got it? Okay, explain why the condition A is not equal 0 must be stated to ensure y equals ax square plus bx plus c equals 0. If A is 0, let's suppose it is 0, y equals 0x square plus bx plus c. It would be 0 times x is 0, it would be bx plus c. So bx plus c is the linear relation. Got it? If A is 0, then the relation would be linear. That's why it is a condition that A must not be equal to 0. Got it? Okay, we are done with the lesson. Please complete the questions. Please complete all the practice questions so the lesson. And if you need more help any of the question, you can contact any tutor on the Skype. They are available from Monday to Friday, 5 to 9. Got it? Do as many practice questions as you can. Got it? So that's all for today. See you in the next session. Bye everyone.